And now, in this lecture, we'll find out the length of line segment X using two different methods. In the drawing, we have quadrilateral ABCD. We know that side AD equals to 3 units, side DC equals to 6 units, and side AB equals to 5 units. In addition, we know that angle ADC equals to 90 degrees. Angle ABC equals to angle DCB equals to theta, and we want to find out the value of line segment X that is actually equals to BC. We want to find out the length of side BC that is actually equals to X. So we'll start with the first method. In the first method, we will extend side BA and side CD by a straight line until they intersect with each other. And we will define the intersection point between the extended side AB and the extended side CD as E. So we actually created here triangle BEC. In triangle BEC, we have two angles. Those two angles are equal to each other, they're both equal to theta. So in the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. I will write it down. In front of equal angles in the triangle, there are equal sides. I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So we will relate to triangle ABC. In triangle ABC, we have two angles that are equal to each other. Here, angle EBC equals to angle ECB. Angle EBC equals to angle ECB, and they are both equal to theta according to what is given us in the question. Therefore, according to rule number 1, in front of those equal angles inside triangle ABC, we have two sides that are equal to each other. That is to say, side EB equals to side EC. Side EB equals to side EC according to this rule, rule number 1. So this is the question number 1. EB equals to 5 plus AE. And EC equals to 6 plus ED. Here we'll subtract 1 from this, we'll subtract 5 from this equation number 1. And we'll get that according to equation number 1, AE equals to 1 plus ED. Here we will define ED as A. ED equals to A. ED equals to A according to our definition. So we'll substitute ED by A in equation number 1, and we'll get that according to equation number 1, AE equals to 1 plus ED, but ED equals to A, so we'll substitute ED by A. So we found out that according to equation number 1, AE equals to 1 plus A. So here AE equals to 1 plus A. Actually before we did the construction, we had quadrilateral ABCD. In quadrilateral ABCD, CD is one side of quadrilateral ABCD. I repeat again that CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. So CD is absolutely a straight line, and then when we extended the straight line CD by a straight line, the result must be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line. Therefore EC is a straight line. So we can write down that EC is a straight line, line segment EC is a straight line. Okay? EC is a straight line. EC, line segment EC is a straight line. And we also have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So I write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here on this side of the straight, if you focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. Okay? So which angles we have at this side of the straight line AC at point D? We have here 90 degrees. It is given us the question that this angle equals to 90 degrees plus angle EDA. In total, the sum of those two angles must be equal to 180 degrees according to this rule, rule number 2. So here we'll subtract 90 degrees from this equation and we get that angle EDA equals to 180 degrees minus 90 degrees, it is 90 degrees. So the missing angle, angle EDA equals to 90 degrees. So here we can write down that this angle, angle EDA equals to 90 degrees. And because of the fact that angle EDA equals to 90 degrees, then triangle EDA is a right triangle. The right great triangle, triangle EDA is a right triangle. Therefore, we can implement the Pythagoras theorem on the right great triangle, triangle EDA. And according to the Pythagoras theorem, in the right great triangle, triangle EDA, in triangle EDA, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AE, so the square of the hypotenuse is AE squared. This will be a question number 2, AE squared. Equals to the sum of the squares of the perpendiculars, that is to say, it is equal to AD squared plus ED squared. I'll repeat again, according to the Pythagoras theorem, in the right great triangle, triangle EDA, AE squared equals to AD squared plus ED squared. So according to equation number 2, AE squared, AE is 1 plus A. So we substitute AE by 1 plus A. Therefore, AE squared will be equal to 1 plus A squared. And it is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus ED squared. ED equals to A, so ED squared is A squared. So in conclusion, we found out that according to equation number 2, 1 plus A squared equals to 9 plus A squared. Here we will open the brackets on this side of equation number 2 and we will get that according to equation number 2, 1 plus A squared equals to 1 plus A squared plus 2A. And it is equal to 9 plus A squared. Here we will subtract A squared from this equation, equation number 2. So A squared will get cancelled. We have A squared on both sides of the equation, so A squared will get cancelled. So in conclusion, we found out that according to equation number 2, 1 plus 2A equals to 9. Here we will subtract 1 from this equation, equation number 2. And we get that according to equation number 2, A equals to 9 minus 1 is 8. Here we divide this equation, equation number 2 by 2, and we get that according to equation number 2, A equals to 8 over 2 is 4. A equals to 4. So here we found out that A equals to 4 units, therefore A plus 1 is 5. In the next step we will define angle AED as alpha. We'll focus on the green right triangle, triangle AED. In the green right triangle, triangle AED, cosine alpha equals to, cosine alpha equals to ED over EA. ED over EA. Here ED equals to 4 and EA equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. In the next step, I will present to you a new law, and we will implement the new law in this triangle EBC. The new law is the law of cosines. The law of cosines, that is, it is true in any triangle. So according to the law of cosines, if we have a triangle ABC that could be any triangle, here this is triangle ABC that could be any triangle, and we know that side AB of triangle ABC equals to A units in its length, side AC of triangle ABC equals to B units in its length, and side BC equals to C units in its length. And we also know that the angle between side AB and side AC is alpha. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. And this equation is true in any triangle. Again, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. So we'll implement the law of cosines in our triangle ABC. Triangle EBC. This triangle. Here EB is equal to A, EC equals to B, again we are talking on triangle ABC. And BC equals to C. That is actually X. BC equals to C. And we have already found out that cosine alpha equals to 4 over 5. Here EB, the length of side EB equals to 5 plus 5, that is 10. So EB equals to 10 units in its length. And EC equals to 4 plus 6, that is also 10. So EC also equals to 10 units in its length. So now we will implement the Pythagoras theorem on this triangle ABC. So actually, according to the Pythagoras theorem, we will get that C squared, C is BC, so it is BC squared this will be question number 3. BC squared equals to A squared. A squared is EB squared plus B squared. B squared is EC squared minus 2 times EB times EC times cosine alpha. Okay, so according to equation number 3, we got that BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Here, so BC equals to x. Therefore, BC squared is x squared. And it is equal to A squared. A squared is EB squared, so EB squared is 10 squared. 10 squared is 100 plus EC squared. EC is also 10, so EC squared is also 10 squared, that is 100 minus 2 times EB is 10 and EC is also 10, so it is 2 times 10 times 10 times cosine alpha. Cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5. So in conclusion, according to equation number 3, we found out that x squared equals to 100 plus 100, that is actually 200, minus 2 times 10 is 100, and minus 2 is minus 200, 4 over 5. Here we got that x squared, according to equation number 3, x squared equals to 200 minus 200 over 5 is minus 40 times 4. In conclusion, according to equation number 3, x squared equals to 200 minus 40 times 4 is minus 160. So in conclusion, according to equation number 3, we found out that x squared equals to minus 200 minus 160 is 40. So x squared equals to 40. So here we take out of this equation number 3, and we find out that according to equation number 3, x equals to the square root of 40. And 40 is 4 times 10, so we substitute 40 by 4 times 10. And we get that here the square root of 4 is 2 times square root of 10. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? So we finished with the first method. In the next step, I will present to you how to find out the value of line segment x according to the second method. Okay? In the second method, we'll do another construction. From point A, we draw a straight line on DC in such a way that the straight line will be parallel to BC. Okay? We define the touching point of the straight line from point A in DC is E. I repeat again that we drew the straight line in such a way that AE is parallel to BC. So here AE is parallel to BC according to our construction. In the next step, from point E, we'll draw a straight line on BC in such a way that the straight line will be parallel to AB. Okay? We define the touching point of the straight line from point E and BC as F. I'll repeat again. If EF is parallel to AB according to our construction. So EF is parallel to AB according to our construction. So actually, quadrilateral AEBF, this quadrilateral is a parallelogram. I'll write it down. Quadrilateral AEBF is a parallelogram. A parallelogram. Why? Because it has two couple of sides that are parallel to each other. AE is parallel to BF and AB is parallel to EF. Okay, so quadrilateral AEBF is a parallelogram. And we actually have a new rule, that is rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. We'll write it down. Corresponding angles between parallel lines are equal to each other. I repeat again on rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. I repeat again, according to our construction, AB is parallel to EF. Therefore, according to this rule number 3, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other. That is to say, angle ABC will be equal to angle EFC. I'll repeat again, angle ABC will be equal to angle EFC according to rule number 3, of course. And actually we know that angle ABC equals to theta according to what is given us the question. Angle ABC equals to theta. So from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. Okay, so this angle EFC is also equals to theta. Likewise, because of the fact that according to our construction AE is parallel to BC, you know that AE is parallel to BC according to our construction. Then according to rule number 3, those two angles that are located between the parallel lines AE and BC will be equal to each other. So this angle that is actually angle AED will be equal to this angle that is actually angle DCB. And they are equal to each other according to rule number 3, of course. They are equal to each other according to rule number 3, of course. So angle AED equals to angle DCB. But it is given as the question that this angle DCB equals to theta. So from this equation, angle AED equals to angle DCB equals to theta, we'll conclude that angle AED also equals to theta. Okay. Okay, angle AED is also equals to theta. Here, this angle AED equals to theta. In the next step, I'll present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I'll write it down. The opposite sides are equal to each other. I'll read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we focus on our parallelogram AEBF. In parallelogram AEBF, here P is abbreviation for parallelogram. So in this parallelogram, we know that AB equals to EF. AB equals to EF according to rule number 4, of course. The opposite sides of a parallelogram are equal to each other, therefore AB is equal to EF. But according to what we have been given in the question, we know that AB equals to 5 units. So here we can write down that AB equals to 5 units, and from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5. EF is also equals to 5. So here you can write down that EF equals to 5. In the next step, we will focus on triangle EFC, this triangle EFC. In triangle EFC, we have two angles that are equal to each other, they are both equal to theta. So angle EFC, this angle, is equal to this angle. This is actually angle ECF. This angle is angle ECF, and they are both equal to theta. I repeat again. In triangle FC, angle FC equals to angle ECF, they are both equal to theta. So, according to rule number 1, it states that in front of equal angles in the triangle there are equal sides. We will get that EF equals to EC. EF equals to EC. But we have already found out that EF equals to 5 units, so we can write here that EF equals to 5 units. And from this equation, 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. So here EC equals to 5 units. So what is the length of the short line segment DE? From the drawing it is very easy to see that the length of line segment DE equals to DC minus EC. So actually, DE equals to DC, that is 6 units, minus EC equals to 5 units. So in conclusion, we found out that DE equals to 6 minus 5, that is 1. So DE equals to 1 unit. So here we can write down that DE equals to 1 unit. Now we will implement the Pythagoras theorem on the right small triangle, right small green triangle, triangle ADE, in order to find the hypotenuse AE. So in the right triangle, triangle ADE, according to the Pythagoras theorem, so we focus on the right small green triangle, triangle ADE. In triangle ADE, by PT is the abbreviation for Pythagoras theorem, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is AE and the square of the hypotenuse is AE squared. And it is equal to the sum of the squares from the perpendiculars, that is to say, it is equal to AD square plus DE square. So according to the Pythagoras theorem, the right green small triangle ADE, AE square equals to AD square plus DE square. Repeat again, in the right triangle, triangle ADE, according to the Pythagoras theorem, AE square equals to AD square plus DE square. So AE square equals to AD square. Actually, AD equals to 3, therefore AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is also 1. So in conclusion, we found out that according to equation number 1, AE square equals 9 plus 1, that is 10. So according to equation number 1, AE square equals to 10. Here we take out of this equation number 1, and we get that according to equation number 1, AE equals to the square root of 10 units. Okay, AE equals to the square root of 10 units. Here, AE equals to the square root of 10 units. Now we will implement rule number 4 in parallelogram AEBF. Here, according to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BT, AE equals to BF. So, in parallelogram AEBF, P, relation for parallelogram AEBF, according to rule number 4 that I have already stated, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF. AE equals to BF according to rule number 4. That the opposite sides of a parallelogram are equal to each other. AE equals to BF, but AE equals to square root of 10 units. So we can write here that AE equals to the square root of 10 units. And from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. Here, BF is also equals to square root of 10 units. So, and what is the length of side FC? From the drawing, it is very easy to see that the length of side FC, it is actually equals to BC minus BF. BC minus BF. Again, BC minus BF equals to FC. So FC equals to BC minus BF. FC equals to BC. BC equals to X according to what is given as the question. And we just right now found out that BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So I feel that FC equals to X minus square root of 10 units. In the next step, we will focus on triangle EFC. In triangle EFC, triangle EFC. Triangle EFC is an isosceles triangle because of the fact that EF, side EF equals to side EC equals to 5 units. So triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC equals to 5 units. And we also know that FC is the base of triangle EFC, of the isosceles triangle EFC. So FC is the base of the isosceles triangle EFC. In the next step, from the vertex E, we will draw perpendicular on FC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point E and FC is M. So EM is perpendicular to FC, therefore EM is the height to the base FC. Because if we have a line segment that exists from a vertex of the triangle to any side of the triangle, it will be defined as the height to that side. So EC is perpendicular to FC, that is to say EM is perpendicular to FC, that is to say EM is the height to the base FC. Okay? EM is the height to the base FC because it is perpendicular to the base FC. It is the height to the base FC. Okay? So we can write down also that EM is the height to the base FC. Okay? In the next step, I will present to you a new rule. This is actually rule number 5. According to rule number 5, the height to the base in an isosceles triangle is bisect the base. The height to the base in an isosceles triangle bisects the base. I will read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, the height EM to the base FC bisects the base FC. So if the height EM bisects the base FC, it means that it divides it to 2 equal parts. That is to say, FM equals to MC. FM equals to MC according to rule number 5. And because of the fact that the height EM bisects the base FC, it means that it divides the base into 2 equal parts. So if the first part is FC over 2, then the second part will be also equal to FC over 2. This is the meaning of rule number 5. So FM equals to FC over 2 and MC is also equals to FC over 2. So we can write here that FM equals to FC over 2 and MC is also equals to FC over 2. So we can write here that FC over 2 equals to FM and it is also equals to MC. According to rule number 5, of course. So according to rule number 5, MC equals to FC over 2. That is to say, we already found out that FC equals to X minus square root of 10, and if we divide it by 2, we'll get MC. In conclusion, we found out that MC equals to X minus square root of 10 over 2. Okay, MC, in MC equals to X minus square root of 10 over 2. Okay, this is the value of MC. In the next step, we'll prove that those two right triangles are similar to each other. So we prove that the green right triangle EMC is similar to the small right triangle ADE. But first of all, we'll focus on triangle EMC. In triangle EMC, the right triangle EMC, this angle equals to 90 degrees. This angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. This angle must be equal to 90 degrees minus theta because of the fact that 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, we know that this angle equals to theta, this angle equals to 90 degrees minus theta. For the same reason, this angle must be equal to 90 degrees minus theta. So actually, we found out that those angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we write it down. First of all, we'll put that triangle ADE is similar to triangle EMC, this triangle EMC. So we just right now found out that angle DAE, this angle, is equal to this angle that is actually angle MEC, and both angles they are equal to 90 degrees minus theta, therefore they are equal to each other. Okay? Angle DAE equals to angle MEC, they are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, those two angles they are both equal to theta, therefore they are equal to each other. So angle AED is equal to this angle that is actually angle ECM, and both angles they are equal to theta, therefore they are equal to each other. And finally, those angles they are both equal to 90 degrees, therefore they are equal to each other. So angle ADE is equal to this angle that is actually angle EMC, and they are both equal to 90 degrees. Okay, so in conclusion, we found out that all the angles of triangle ADE are similar to all the angles of triangle ADE can go into all the angles of triangle EMC. Therefore, triangle ADE is similar to triangle EMC according to angle similarity rule. So I write it down. We actually proved that triangle ADE is similar, this is the sign of similar, to triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude hence that AE over EC is equal to DE over MC. I repeat again, from the fact that triangle ADE is similar to triangle EMC, we will conclude that AE over EC equals to DE over MC. So here AE equals to square root of 10 units. EC equals to 5 units. And it is equal to DE that is equal to 1 unit over MC that is equal to 1 over, it is actually equals to x minus square root of 10 over 2. X minus square root of 10 over 2. So in conclusion, we found out that according to equation number 2, square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we'll move to the numerator and x minus square root of 10 to the denominator of this side of equation number 2, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. So according to equation number 2, square root of 10 times x minus square root of 10 equals to 10, but we'll substitute 10 by square root of 10 times square root of 10 because square root of 10 times square root of 10 equals to 10. Here we'll divide this equation by square root of 10, and we'll get that according to equation number 2, here square root of 10 over square root of 10 is 1, so we're left only with x minus square root of 10, that is equal to square root of 10 times square root of 10 over square root of 10 is square root of 10. Here we will add square root of 10 to this equation number 2, and we'll get that according to equation number 2, x equals to square root of 10 times square root of 10, that is actually 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. I'll repeat again, x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. In the next step we will summarize the lecture. We'll start with the first method. I repeat on the question, we have here quadrilateral ABCD, side AB equals to 5 units, side AD equals to 3 units, side DC equals to 6 units, and angle ADC, this angle equals to 90 degrees, angle ABC equals to angle DCM, they are both equal to theta. And we want to find out the length of side BC that is actually equals to x. So in the first method we did a construction with side AB and side DC by straight line until they intersect with each other at point E. Point E is the intersection point of the extended BA and the extended CD. So we created here a triangle BEC. In triangle BEC we have two angles that are equal to each other, they are both equal to theta. Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. Okay? So according to rule number 1, in front of those two equal angles in triangle EBC, we have equal sides. That is to say, EB equals to EC. I'll repeat again. According to rule number 1, EB equals to EC. So here EB equals to 5 plus AE. Okay, EB equals to 5 plus AE, and EC equals to 6 plus ED. 6 plus ED equals to EC. EC equals to 6 plus ED. So according to equation number 1, 5 plus AE equals to 6 plus ED. Here we subtracted 5 from this equation, equation number 1, and we found out that according to equation number 1, AE equals to ED plus 1. We defined ED as A, here ED equals to A according to our definition. So we substituted ED by A in equation number 1. So AE equals to 1 plus ED plus, but it is A equals to 1 plus ED, but AD equals to A according to our definition. So we substituted ED by A, and we got that A equals to 1 plus A. See, so here A equals to 1 plus A. Okay? Then, actually, before we did the construction, we had quadrilateral ABCD. In quadrilateral ABCD, side CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. CD, line segment CD, is one side of quadrilateral ABCD, it must be a straight line. And then when we extended the straight line CD by a straight line, the result must be a straight line. Because when you extend the straight line by a straight line, the result must be a straight line. So the result that is CE must be a straight line. So we can write here that CE or EC does not matter at all. EC equals, it is a straight line. Okay, EC is a straight line. Then I presented to you I presented to you rule number 2, that according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have 90 degrees, and we have angle ADE. This angle is angle ADE. So here 90 degrees plus angle EDA must be equal to 180 degrees according to rule number 2. Then we subtracted 90 degrees from this equation and found out that angle EDA equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle is a right angle. So if angle EDA equals to 90 degrees and it is a right angle, it means that the green triangle AED is a right triangle. So we can implement the Pythagoras theorem on the right green triangle, triangle EDA. So in the right triangle, triangle EDA, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AE, so the square of the hypotenuse is AE square, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD square plus ED square. AE equals to 1 plus A, so A square is 1 plus A square. AD equals to 3, so AD square is 3 square, that is 9. ED equals to A, so ED square is A square. So in conclusion, we found out that 1 plus A square equals to 9 plus A square. We open the brackets on this side of equation number 2, and we got that 1 plus A square equals to 1 plus A square plus 2A, that is equal to 9 plus A square. Here we have A square on both sides of equation number 2, so A square will get cancelled, and we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation, equation number 2, and found out that 2A equals to 9 minus 1, that is 8, so 2A equals to 8. We divided equation number 2 by 2, and we got that 2A equals to 8 over 4, that is 8 over 2, that is 4. So we found out that here A equals to 4 units, therefore A plus 1 will be equal to 5 units. Okay, then we defined angle AED. This angle is alpha. So in the green triangle, the green right triangle, triangle AED, we know that in the green right triangle AED, we know that cosine alpha equals to ED over EA. Cosine alpha equals to ED over EA. ED equals to 4, EA equals to 5, so in conclusion we found out that cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in this triangle, triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle, so if we have this triangle, triangle ABC, that could be any triangle, and we know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units, and the angle between side AB and side AC is alpha. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine alpha. So we can implement the law of cosines in our triangle EBC, the big triangle, triangle EBC. Here, side EB equals to A, side EC equals to B, and side BC equals to C. We have already found out that cosine alpha equals to 4 over 5. EB equals to 5 plus 5, that is 10. EC equals to 4 plus 6, that is also 10. So here, according to the law of cosines, and BC equals to, and C equals to BC, that is actually equals to X. So according to the law of cosines, we get that C square is BC square, that is equal to EB square plus EC square minus 2 times EB times EC times cosine alpha. This is equation number 3. So here BC equals to X, so BC square is X square, so we substitute BC square by X square. EB is 10, so EB square is 10 squared, that is 100. EC is 10, so EC square is 10 squared, that is also 100. And minus 2 times EB is 10, and EC is also 10, times cosine alpha is 4 over 5, so we substitute cosine alpha by 4 over 5. So in conclusion, we found out that according to equation number 3, x squared equals to 100 plus 100 minus 2 times 10 times 10 times 4 over 5. So x squared equals to 100 plus 100 is 200, and here we have minus 10 times minus 10, 10 times 10 is 100, and 100 times minus 2 is minus 200. So this expression, in conclusion, equals to minus 2 times 4 over 5. So in conclusion, we found out that according to equation number 3, x squared equals to 200 minus 200 over 4 over 5. 200 times 4 over 5. So x squared equals to 200, and minus 200 over 5 is minus 40. So this expression equals to minus 40 times 4. So in conclusion, we found out that x squared equals to 200 minus 40 times 4. So x squared equals to 200, and minus 40 times 4 is minus 160. So in conclusion, we found out that x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, we found out that x squared equals to 40 according to equation number 3. Here we took a root from this equation, equation number 3, and we found out that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equals to 6.32 units. Then I presented to you how to find out the length of line segment BC according to the second method. In the second method, we did another construction. here from point A, we draw straight line on DC in such a way that AE will be parallel to BC. So AE is parallel to BC according to our construction, and then from point E we drew a straight line on BC in such a way that EF will be parallel to AB. Again, EF is parallel to AB according to our construction. So quadrilateral AEBF is a parallelogram. Why? Because it has two couple of sides that are parallel to each other. And any quadrilateral that has two couple of sides that are parallel to each other is defined as a parallelogram. So quadrilateral AEBF is a parallelogram. Okay? So then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So according to our construction, AB is parallel to EF. Here, side AB is parallel to side EF. Therefore, those two corresponding angles will be equal to each other according to rule number 3. Why? Because those two corresponding angles are located between the straight line and the parallel lines AB and EF. Therefore, they are equal to each other according to rule number 3. I'll repeat again. Angle ABC equals to angle EFC according to rule number 3. But angle ABC equals to theta according to what is given as the question. So we can write here that theta equals to angle ABC equals to angle EFC. So from this equation we will derive that angle EFC is also equals to theta. So this angle EFC also equals to theta. Then, because of the fact that AE is parallel to BC according to our construction, we will derive from it that those two angles are equal to each other according to rule number 3. Because of the fact that AE is parallel to BC, angle AED must be equal to angle DBC according to rule number 3. But angle DBC equals to theta according to what is given as the question. So we can write here that angle DBC equals to theta. And from this equation, angle AED equals to angle DCB equals to theta, we will derive that angle AED is also equals to theta. So this angle AED equals to theta. Okay? Then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. Okay? So we relate to our parallelogram AEBF. According to rule number 4, its opposite sides are equal to each other. That is to say, AB equals to EF according to rule number 4. In parallelogram ABF, AB equals to EF according to rule number 4, but AB equals to 5 units according to what is given as the question. So here from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. So here we can write down that EF also equals to 5 units. Okay? Then we focused on triangle EFC. In triangle EFC, we have two angles that are equal to each other. In triangle EFC, angle EFC equals to angle ECF, and they are both equal to theta. Therefore, according to rule number 1, that in front of equal angles in the triangle there are equal sides, we will derive from it that EF equals to DE. EF equals to EC. Here, in front of those two equal angles, there are equal sides. That is to say, EF equals to EC. EF equals to EC according to rule number 1. But EF equals to 5 units. So can I write here that EF equals to 5 units? And from this equation, 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. Then what is the size of the length of the small line segment, the short line segment DE? DE, from the drawing it is very easy to see that DE equals to DC minus EC. Here DE equals to DC minus EC. So DE equals to DC, DC equals to 6 units according to what is given in the question. EC equals to 5 units according to what we have already found out. In conclusion, found out that DC equals to 6 minus 5, that is 1. So DE equals to 1, then we focused on the small right triangle, triangle ADE, and then we implemented the Pythagoras theorem on this small right triangle, triangle ADE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AE, and the square of the hypotenuse is AE squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that AE squared, according to equation number 1, equals to 9 plus 1. 9 plus 1 is 10, so according to equation number 1, we found out that AE squared equals to 10. We took out of this equation number 1, and we found out that AE equals to the square root of 10 units. Here AE equals to the square root of 10 units. Now we can implement rule number 4 in the parallelogram AEBF. According to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF according to rule number 4. In parallelogram AEBF, AE equals to BF according to rule number 4. But we just now found out that A equals to the square root of 10 units. So from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. Here, BF is also equals to square root of 10 units. Then, what is the length of side FC? FC equals to BC minus BF. Again, BC minus BF equals to FC. Here, FC equals to BC minus BF. So FC equals to BC, that is X, and BF equals to square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. Here, BF equals here FC equals to X minus square root of 10 units. Okay? Then we actually focused on triangle EFC. In this triangle EFC, side EF equals to side EC. Therefore, triangle EFC is an isosceles triangle. I repeat again. In triangle EFC, side EF equals to side EFC, therefore triangle EFC is an isosceles triangle. In addition, we know that FC is the base of the isosceles triangle, triangle EFC. Again, FC is the base of the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. And here, from the vertex E, we draw a perpendicular on FC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and FC as M. Okay, so EM is perpendicular to FC. What does it mean? It means that EM is the height to the base FC. EM is the height to the base FC. Okay, EM is the height to the base FC of the isosceles triangle, triangle EFC. Then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, the height EM to the base FC bisects the base FC. What does it mean that it bisects the base? It means that it divides the base into two equal parts. So if this part is FC over 2, the other part must be also equal to FC over 2, because FC over 2 plus FC over 2 is FC. So each part is FC over 2. and it divides the base into two equal parts. That is to say, FC equals to MC according to rule number 5, and each part equals to FC over 2. So here FC equals to MC according to rule number 5, because it bisects the base. It means that it divides it to two equal parts. It means that FM equals to MC according to rule number 5. And what is the length of each part? Each part equals to FC over 2. That is to say, FM equals to FC over 2 and MC also equals to FC over 2. So in conclusion, we found out that FC over 2 equals to FM equals to MC, according to rule number 5. So according to this equation, MC equals to FC over 2. That is to say, MC equals to FC, that is x minus square root of 10 over 2. So in conclusion, we found out that MC equals to x minus square root of 10 over 2. Here, MC equals to x minus square root of 10 over 2. Then we proved that those two right green triangles are similar to each other. Why those two right green triangles are similar to each other? First of all, in this right triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right green triangle to 180 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For that reason, this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta, because it has here 90 degrees theta. This angle must be equal to 90 degrees minus theta. So actually we found out that those two angles, they are each equal, they are both equal to 90 degrees, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, angle DAE equals to angle MEC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So in conclusion, we found out that the right triangle ADE is similar to the right triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. Here, AE over EC equals to DE over MC. Again, AE over EC equals to DE over MC. AE equals to the square root of 10 units. EC equals to 5. DE equals to 1, and MC equals to x minus square root of 10 over 2. So in conclusion, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we move 2 to the numerator and x minus square root of 10 to the denominator. And in conclusion, we found out that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Because multiplied this equation number 2, and found out that square root of 10 times x minus square root of 10 equals to 10, because 5 times 2 is 10. Here we substituted 10 by square root of 10 times square root of 10, and we got that square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10, that is 10. We divided this equation number 2 by square root of 10, and we found out that square root of 10 times square root of 10 is 1, so we left here in this side of equation number 2 only with x minus square root of 10, and it is equal to square root of 10 times square root of 10 over square root of 10, that is square root of 10. We added square root of 10 to this equation number 2, and we got that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So in conclusion, we found out that x equals to either 2 times square root of 10, or in terms of numbers, it is equal to 6.32 units. So we arrived to the same result in both methods. Okay, thank you very much.